8.5, using intercept form. Okay, so intercept form is going to look like this. So the a is going to be some number, and the p and the q are going to be some numbers. Okay, so it would look something like this. This is an equation. The a would be 1 here. Okay, but so the x-intercepts are going to be the points p and q. They're going to be, so whatever the p value is will be one of the x-intercept, and same with the q value there. Okay, when the a is positive, the parabola opens up, and when a is negative, it's going to open down. So that is useful to keep in mind always. Okay, and the axis of symmetry, remember that's the line, that's the vertical line that's going to be right in the middle of a parabola. And since it's in the middle of the parabola, it means it's going to be halfway between the x-intercepts. So we're going to use that concept to help us find it. Okay, halfway between the x-intercepts. All right, so on this example, let's find the x-intercepts first. So it's going to be the points p and q. Remember, if you're looking for an x-intercept, you would plug in a 0 for y. And so I'll plug in 0 where the f of x is here. And then if we solve this for x, I can now use the zero product property. I got two things multiplied together that equals 0. So that means one of these two things, it has to be 0 times something or something times 0. So either x plus 2 equals 0 or x minus 4 equals 0. And then when I solve those, x is going to equal negative 2 or positive 4. Okay? Now you don't really have to go through that, that whole process every time finding the x-intercepts if you know where to look. So that's going to be one of my x-intercepts because a 4 is subtracted. But then in the first parentheses, it doesn't. There's nothing subtracted. In the formula, it's whatever you're subtracting from x in both those positions, right? But you could think of that first parentheses as x minus negative 2, and then x minus 4, and that's why the x-intercepts are negative 2 and positive 4, okay? Because it's what you're subtracting from the x's. Okay, so if it's written as a plus, you could think of it as a double negative. So in other words, you can just change the sign of these two things, and that will give you your x-intercepts, which is exactly what happened. Okay, so now let's graph those x-intercepts. I got an x-intercept at negative 2 and another one at positive 4. Okay, so next I want to graph the axis of symmetry. So I know it's a vertical line that's in the middle of my parabola, and I know any point on the parabola is going to be reflected over the line of symmetry. So that means the line of symmetry should be it should be right in between, in the middle of the two x-intercepts, so that they reflect onto each other over that line. Okay? So what I can do here is just like, okay, how far is this from one end to the other? So I'm going from negative 2 to positive 4. That means that's 6 total units, right? So if I cut that in half, if I go 3 units from either end, 1, 2, 3, or 1, 2, 3, then this is going to give me the placement of my axis of symmetry. Okay, so now I'm just drawing a vertical line that goes through that point. Okay, I've graphed the axis of symmetry. Now I'm going to find the vertex. So I can see from this one the a value is 1, right? Because I can put a 1 out there. So that means this one opens up. Kind of makes sense with the graph we're provided here. So the vertex is going to be somewhere down here, and it's also it has to be on the axis of symmetry. So every point on this axis of symmetry is going to have an x-coordinate of 1, because this is the line x equals 1, right? We've got 1, 0, 1, negative 1, 1, negative 2. So the x has to equal 1 for the vertex. So now I know the vertex is going to be the point 1 something, and I just need to figure out what that something is. Okay? And the way I'm going to do that is use the equation. So I'm gonna find out what y goes with an x of 1. So I'm just gonna treat the f of x as y here. So I'm plugging in 1 into the equation in both positions for the x. like so. Okay, so I plugged 1 in for both x's. Now I'm going to start simplifying. So I'll do the parentheses first. That means I'm doing the addition here. And here I've got subtraction. So 1 minus 4 would be negative 3. And now I'll do the multiplication. 3 times negative 3 would be negative 9. So that's the y-coordinate that goes with an x-coordinate of 1 on this parabola. And it just barely fits on this graph, right? 1 right, 9 down. There it is. There's my vertex. Okay, and now I can draw a really good parabola with just that information. So, and you could get more points if you wanted to by making an xy table, right? You could plug in 2 for x or 3 for x or whatever and find some more points if you wanted more. But 3 points is plenty to draw a pretty decent graph of a parabola. Okay, all right, let's try another one. So this one, a little different because I've got my a value here is negative. So this is telling me that this is going to open down. Just good to keep in mind when I graph this, okay? And then let's look for the x-intercepts. So you can take both of the parentheses and set them equal to 0, but you can also just think what's subtracted from each x. Well, positive 2 is subtracted here. So that means one of my x-intercepts is going to be 2. You could say that it's the 0.20 if you wanted, or you can just say the x-coordinate is 2. So x would equal 2. That's one of my x-intercepts. And then when I do this parentheses, I'm thinking, okay, let's write that as a double negative so that I've got negative 1. Okay, because it's what's subtracted, so a negative 1 is subtracted, or just change the sign of the 1. So x equals negative 1. So there's my two x-intercepts. Let's go ahead and graph them. Okay, I got negative 1 and positive 2. Okay, next I'm going to find the axis of symmetry, which is going to be halfway between those. Now, this is a little interesting because if you count the number of units, these are 3 units apart from each other. So when I cut that in half, well, I need to go 1.5 units from either end because that's half of 3, right? So the middle is going to be right there. So it's not an integer. It's going to be right there, half a unit to the right of the y-axis, okay? So the equation of that line would be x equals 1/2 or x equals 0.5, and that means I know that the x-coordinate of the vertex is going to be 1/2 or 0.5, okay? So I know that part already. Now I just have to find the y that goes with that x. So I'm using the equation, and I'm going to plug in 0.5 for both x's. And I've got 0.5 plus 1 here. Okay. So then now let's start simplifying this. I'll start inside the parentheses here. 0.5 minus 2 would be negative 1.5. Okay, and then 0.5 plus 1 would be 1.5. Okay, so I'm going to multiply this. A negative times a negative is positive. I'm multiplying those two first. So that 2 times 1.5 would be 3. Now I've got 3 times 1.5. Okay, and 3 times 1.5 is going to come out to 4.5. I'll just go that way since I ran out of space. Okay, so that's my y-coordinate then. So 4.5 is the y-coordinate. So now let's go ahead and plot that point. 0.5 and 4.5 up would put me right here. And then I just draw the parabola, and you can see it's going to open downward just like we predicted at the beginning. Something like that. All right, the next problem, we're going to do a similar problem, but it's a little trickier because if you look on this page, this isn't in vertex form, right? It's not in that format where I have the parentheses. But that's okay because we can get it in that format by factoring it. Okay, so that's one of the main reasons we did all the factoring in the previous sections. Okay, so I'm looking at this and thinking, all right, is there a common factor? That's always what I'm looking for first. Is there something that goes into both terms? And there is here. 3 goes into both terms. So I'm going to factor out a 3. And I'm kind of just thinking about, well, if I had to distribute 3 to something to get this, 3 times something is 3x squared. That would be x squared. 3 times something is negative 3. That would be negative 1. Okay, so it's factored now. But is it completely factored? And it's not actually, because if you look at this binomial here, we can factor that further. It's a difference of squares. This is a perfect square, and this is a perfect square, and the negative makes it a difference. So x times x is x squared, and 1 times 1 is 1, right? So if you remember the pattern of a difference of squares, it's going to factor into x plus 1 times x minus 1. Okay, so now this is completely factored. There's no more factoring that you can do there. And now it's in the right format for, now it's the same as the previous problems, right? It's in x-intercept format. Okay, so let's find the x-intercepts. So this is going to give me an x-intercept of negative 1 here. And this is going to give me an x-intercept of positive 1. I'm just changing the sign of both of those things to make it quick here. Okay, so I'll graph those, negative 1 and positive 1. Okay. And then let's graph the axis of symmetry. Well, it's going to be directly between those 2 points, which makes this the y-axis, right? So if you think about what the points on the y-axis are, you got 0, 0, 0, 1, 0, 2, 0, 3. All the x's are 0, right? So any point on that line, including the vertex, is going to have an x-coordinate of 0. So I just need to find the y that goes with that, and then I'll use the original equation. You could use the original one actually, or the factored one. It doesn't really matter. I might use the original one because there's only one place to plug in the x then, but it doesn't really matter. Okay, and I just like to use y for this because I'm looking for a y coordinate. So I'm plugging in 0 for x. So I'm using PEMDAS. I do the exponent first. 0 squared is just 0. And then 3 times 0 is 0. And then I get negative 3. Okay, so there is my vertex, 0, negative 3. Now I can see this one is going to open up, which makes sense because the A is positive. Okay? And there is my graph. Okay? All right. So let's talk about zeros of a function. Zeros of a function, I think we've talked about these a little bit already, but that's the x values when the function equals 0. So in other words, it's the x values when the y equals 0. So what we need to do to find zeros is set the function equal to 0, factor it, and then set each factor equal to 0 and solve, which is what we were doing here. That's how we were finding the x-intercepts, okay? We were really plugging in 0 for y and then solving for x, and you had to factor it in order to get there, okay? So let's try it out on some examples here. So I'm going to plug in a 0 for f of x, so that's setting the function equal to 0. Okay, now this one is already factored. There's no more factoring I can do, so that means I can go straight to the 0 product property. Either x minus 6 equals 0 or x plus 1 equals 0, and that means x is going to equal 6 or negative 1 when I solve both those equations. Okay. All right, this next one is not factored, so I got to factor it myself. So first thing I'm looking for is a common factor, and I'm seeing 3 goes into everything. So I'm going to plug a 0 in for f of x, and then I'm going to factor out a 3. Okay, and I'm thinking 3 times something is 3x squared. That would be x squared. 3 times something is negative 12x. 3 times something is 12. Okay, so I got it down to that. Now I want to think, is there any more factoring I can do? Well, I have this trinomial. So let's see if we can factor that further. There's no common factor, but we can factor this using a diamond problem, or we can try to at least. So I'd put the negative 4 on top. We did this in a previous section. So I'm looking for 2 numbers that add to negative 4, and the same 2 numbers multiply to positive 4. And you just kind of play around. If I did like 1 times 4, I can't get a negative 4 out of that, or negative 1 times negative 4. But if I use 2's, 2 times 2 would give me a positive 4 when I add them, but if I use negative 2's, then that's going to work out, right? Those multiply to positive 4 and add to negative 4. Okay? So that means when I factor this, I know I have x's out front when I'm thinking about foiling this to get the x squared, and the solution to the diamond problem, the negative 2's, is what goes in the back of those parentheses. Okay? Now this is factored, and I can use the zero product property. So one of these three things has to equal 0. Well, 3 can't equal 0, right? So, you know, if you say 3 equals 0, well, no, it doesn't. So it doesn't make sense. You just throw it out then. Now, these other two, you get the same thing because they're the same, right? Either one, x minus 2 equals 0, and then when we solve that, x equals 2. So that means that this would be a parabola if you graphed it. It would just have one x-intercept. So that means the vertex would have to be on the x-axis. Okay. All right. Let's look at this next one. So let's look for a common factor again. So I'm going to plug in 0 for y. And then, hey, both those terms have an x. So let's factor out x. Okay. And don't throw away this x. I see people do that a lot and say, oh, I just divided everything by x. But that's still a factor that we're going to use. Okay. Now, this isn't completely factored yet because I've got a difference of squares here, which I can factor further. They're both perfect squares, and they're subtracted. So x times x is x squared, and 3 times 3 is 9. So you got to know the pattern here for a difference of squares. This is going to factor into x plus 3 times x minus 3. Okay? Now I've got this completely factored. There's not always going to be 2 factors like problem A. This one has 3 factors, and all 3 of them are going to lead to a different 0. So if x equals 0, well, there's nothing to do there. That's just one of my zeros. Okay? Or if x plus 3 equals 0, then x equals negative 3. And if x minus 3 equals 0, then x equals positive 3. All right, next page is going to be a little trickier. So here we're going to be writing a quadratic equation in standard form from the vertex. So if you look at this example, all we're given is the vertex, and we're going to write an equation in standard form. So standard form is this. You got to know what that looks like. So no parentheses, right? It's just y equals ax squared plus bx plus c. So maybe y equals 2x squared plus 3x plus 4 or something like that. Okay? So the way we're going to start is by using vertex forms, and so that's all we know. And the vertex is the coordinates are going to be the h and k in vertex forms. I'm going to plug those in those 2 positions to begin with. Okay? I'm going to use a y here instead of f of x to make it a little simpler because we're going to be plugging something in there. Okay, so x minus my h is 2, and then I'm squaring. And then plus the k, which is 5. Okay? Now, there are many different parabolas that have a vertex at 2, 5. It could open upwards or down. It could be a very wide parabola or a very narrow parabola. It doesn't say in this problem if it opens up or down or how wide or narrow it is. And all those things depend on the a value. So that means that this a value can be anything we want, with one exception. You can't have it be 0 because then you'd have 0 times this parentheses, and then it would just be y equals 5. It wouldn't be a parabola anymore. But it can be anything else. So the best thing to use for a, in my opinion, is 1. So I'm just going to say, okay, if a is 1, then this is what this is going to look like. Okay? And now all I have to do is put this in standard form. I could have left this as f of x. I was thinking of another problem where that would make it simpler. But anyway, so I want to multiply this out. Now, I'm going to use PEMDAS to get rid of the parentheses to put it in this form. A lot of people are just going to square the x and the negative 2. They'll say x squared plus 4 plus 5. But that's actually incorrect, because when you square a binomial, you want to think of multiplying it by itself, because you're going to have to FOIL. Okay? So when you FOIL this, first, outer, inner, last. First, x times x is x squared. Outer, the pieces on the outside, x times negative 2 would be negative 2x. Inner, negative 2 times x is negative 2x. And last, negative 2 times negative 2 is positive 4. Okay, now that was just for the two binomials, so I still have the plus 5 at the end, right? So this is from squaring the binomials. But this would look the same without parentheses because we're just adding to the end, okay? So now all we have to do is combine like terms. So we've got like terms here, and we've got like terms here. So you can say y equals or f of x equals. So x squared minus 4x plus 9. Okay. All right, not too bad. Okay. This is a different type of problem here because we have different given info. Okay. If you look at this problem, we don't necessarily have the vertex. We're not told that any of these are the vertex, but we do have two x-intercepts and a through point. Okay. So let's talk about the x-intercepts. We're given these three. It doesn't tell me which two are x-intercepts, so I got to figure that out. Now, if you graph these 3 points, if you plotted them on an xy axis, 2 of them would be on the x-axis. Now, you don't actually have to do that, but if you think through this, 3, 0, well, you go 3 to the right, 0 up, so you'd still be on the x-axis. And if you went 5 left, 0 up, you'd be on the x-axis. But if you went 4 right, 18 up, you would not be on the x-axis. So that means that these two are our x-intercepts. And it's important to distinguish. That means this one's going to be the through point. Just any random point that that is on the parabola, that the parabola goes through. Okay. So when I talk about the x-intercepts, these are the coordinates, but you can also just refer to where they cross the x-axis. Okay. And the place these cross the x-axis would be at 3 and -5, right? So when we're using intercept form, these are the x-intercepts. So that means that this is going to be P and this is going to be Q. Okay? So what I'm going to do first is substitute the x-intercepts into this equation. Okay, so I've got f of x, and here I am going to use the y instead of f of x. Didn't need to do it in the last problem, but it's going to be helpful here. Okay, I don't know about a yet, so I'll leave that alone, but I got x minus p, and p is 3, and then x minus q, and q is -5, so I'm subtracting -5, so I'm going to rewrite that as a positive. Okay. All right, now the next step, I'm going to substitute in the through point. So I substituted in the x-intercepts, now I'm going to substitute in the through point. So, you know, this was my p value, and this was the q value, right? And I'm going to think of this as x and y for my through point. So I'm going to plug the x and y in these positions. So let's see, let's put an 18 right here. I'll leave that as a, and then for the x, I'm going to put in 4. For the other x, I'm also putting in 4. Okay? And now my goal is to figure out what a equals, and I can do that now because it's the only variable left in this equation. So let's start simplifying on the right side. 4 minus 3 is 1, and 4 plus 5 is 9. So I could write 18 equals, this would be 9a if I multiplied it all together. Now to solve for a, just dividing by 9, and a is going to equal 2. Okay? So if you look at the steps that I've listed above, we substituted, then we solved for a. Okay? Now the next step, we're going to plug in a and the x-intercepts into intercept form. So I'm going to take this equation again, and I'm going to be plugging in these 3 parts. Okay? So let's go ahead and do that. So you could put f of x in again. I just had the y there because when I plugged in 18 for y, I didn't want that to throw people off. Okay, but f of x or y, whatever. And now I know the a value is 2. Okay, and x minus p, so the p value was 3. And then x minus q. Q value is -5, and again I got that double negative, so I want to write it as a positive. Okay. All right. So now I've got my equation. It really looks just like this, except with that a value plugged into it. Okay. And the last step, I want to convert this to standard form. So the way I'm going to do that is by doing all the multiplication on the right side. Okay. So you could distribute the 2 first if you wanted, or you could do the foiling first. It doesn't really matter. So I'm going to distribute 2 first. Okay, that's what it looks like with the 2 distributed. And now I'm going to do another round of foiling. Okay. Oh, I said, whoops, that's just 2x, not 2x squared. Okay, so now I'll do one more round of foiling to multiply these binomials together. And I've got 2x squared. Okay, sorry about the phone there. Okay, so first 2x times x is 2x squared. Outer 2x times 5 would be 10x. Inner, negative 6 times x is negative 6x. And last, negative 6 times 5 is negative 30. Okay, and then I want to combine the like terms here. And I've got 2x squared plus 4x minus 30. And there's my solution. Okay. All right, last page. There's a whole lot in this section. So we're going to look at cubic functions. Okay, and intercept form of a cubic function looks very similar. It just has a third x-intercept. Okay, so and the x-intercepts are going to be points p, q, and r. So let's look at graphing a cubic function using zeros. Okay, so it's really the same type of process. So we want to take this and factor it so that we can use the zero product property to find the x-intercepts. So x-intercepts, remember the y-coordinate's going to be 0, so I'm plugging a 0 for that. Now on the right side, I'm looking at this and thinking, does anything go into x to the third, x squared, and negative 6x? And yeah, they all have an x, right? So then I'm thinking of distributing x times something is x to the third, that would be x squared. X times something is x squared, that would be x. X times something is negative 6x, that would be negative 6. Okay, so I factored out an x. Don't throw away the x, it's important. It's a factor that we're going to need. Okay, but I want to keep factoring this, and I can still factor this trinomial. So I'm going to use a diamond problem here. I'm going to use the b, which would be 1 from right there, and the c is negative 6. So I'm looking for two numbers that add to 1 and multiply to negative 6. So I'm just going to start brainstorming here. Let's see. To multiply to get negative 6, I could do that, but that doesn't add up to 1. That doesn't add up to 1 either. That adds up to negative 1. This adds up to positive 1, and there is my winner. Okay? So that is going to help me to factor this trinomial. It tells me what's going to go in the back of the parentheses. I know I have x's up front because if you FOIL this, that's how you get x squared, right? The negative 2 and the 3 are what goes in the back. Now I've got this factored, and I've got it set equal to 0, so now I can use the zero product property. One of these three factors has to equal 0 in order for it all to multiply together to equal 0. So either x equals 0, well, that's one of my x-intercepts. Or if x minus 2 equals 0, that means x equals 2. And if x plus 3 equals 0, x equals negative 3. Okay, so those are my zeros. Okay, so we factored. We found the zeros. Now we're going to graph the zeros. Those are x-intercepts. So I've got one at 0, one at positive 2, one at negative 3. Okay, and cubic functions are typically going to look like an S-curve. Okay, so they might look something like this, or they could look something like this. So it's a little hard to tell which way our S-curve is going. So in other words, should we start, and go down like that, or should we start from the bottom and go up? Well, at this point, the best way we can figure that out is by choosing, making an XY table and choosing a few more points. Okay, so here I'm going to use this this space up here. Let's say when x equals, I'll try x equaling negative 4. Okay, and the way I can figure this out is to plug an x value into this. So I'm going to think, okay, what would y equal if x was negative 4? Okay, and I got a lot of work there to do to sort that out. So I'm going to use a calculator to make it a little quicker. So I've got negative 4 to the third, and when I put that in my calculator, I'm going to do it in parentheses like that. it's going to come out negative because it's a negative times a negative times a negative. Okay, so I got negative 64, and then negative 4 squared is 16 because it's negative 4 times negative 4. Negative 6 times negative 4 would be 24. Okay, and then let me use my calculator here. Negative 64 plus 16 plus 24. That's going to come out to negative 24. Okay, so that means that the point negative 4, negative 24 would be on this graph. So that's way down here somewhere. Okay, so just in the interest of time, I could choose another point in between these x-intercepts and another one here and another one here, but those are going to alternate. So just a real basic S-curve. I'm just going to make it start down here somewhere because I knew there was a point down here. Then I'll cross here, and then I'll have to turn around to cross again, and I'll have to turn around to cross again. So I'm not getting the exact shape of this, so I didn't know how high to go on this hill and how low to go on this valley, but I've got the general shape there. I've got the x-intercept, and I knew the S-curve was going in that direction. Okay, and you can get more accurate by going into more detail on your XY table. Okay. All right, let's look at the last problem in this giant section. Okay, writing a cubic function from x-intercepts and a through point. I need to take that out. I got a typo there. Okay. So we've got, this says the zeros of a cubic function are these. The function passes through this. Okay. So what we're going to do is use intercept form. This is a very similar process to the one on the last page when we had a quadratic function. It's just cubic. Okay, so this is going to be, instead of just being P and Q for my x-intercepts, now I have an R as well. So I'm going to plug those three things in to those positions. Okay, so I'm going to say, I'm going to use y instead of f of x here. I'm going to do x minus negative 3, x minus negative 1, and x plus 1. Sorry, x minus 1, sorry. Whoops. All right, so I'm just subtracting all three of these, the P, Q, and R from x, just like it is up there. Okay, now I'm going to simplify this a little bit. So x minus negative 3, that would be positive 3, and x minus negative 1 is positive 1. Okay, now that's the first step. Well, it's the first two steps. And then we're going to plug in the coordinates of the through point. So we plugged in the x-intercept. Now we're going to plug in the through point for x and y. So this is going to be x and y. Okay, so I'm going to plug in 0 for x and negative 3 for y. So I'm going to put a negative 3 there. I'm going to put in 0 for all three of the x's. Okay, now I'm going to start simplifying this, so I'll do the work in the parentheses first. So just doing the arithmetic in the parentheses, and now I'll do the multiplication out here. Let's see, 3 times 1 is 3. Take the opposite of that, negative 3. So now I've got negative 3 equals, this would be a times negative 3, so negative 3a. Okay, now what I'm trying to do here is solve for a. So I'm going to divide by negative 3, and now I can see a is going to equal 1. Okay, so we plugged in the through point, and now we solve for a, and now we have everything we need. So it's going to look just like this. We're going to plug in the P, Q, and R, but we also need the a value, which I now know is 1. So I can say now that this is, you can write out the 1, but you don't need it, right? Because it'd be redundant. But I've got x plus 3, x plus 1, and x minus 1. And yeah, this would be the a value of 1 there. So it looks the same without writing the 1. Okay? All right, that's the end of the section, and I'll see you next time.